หนึ่ง So in this would be chapter 1 introduction, and in this introduction to electric railway engineering fundamentals course of my or the M&E system that I just mentioned. This course is aimed to introduce the students to basic fundamentals of the electric railway system. Like I said, better known in the industry as the M&E system, part of the modern mass transit systems, especially those currently in operation in Thailand. And there are many universities in Thailand that are teaching railway engineering courses. But one could envision that when we are talking about railway engineering, which is one of the most talked about field of engineering nowadays in Thailand. And like I said, the relevant subjects and all courses have been taught in many universities in Thailand. So for the railway engineering courses, one should assume that we would be talking about electric railway system, because that is what is happening and will be happening in the future in Thailand, not the regular diesel locomotive railway system that we are also seeing in Thailand. But like I said, most of the railway engineering curriculums in Thailand, in most of the university, they are not really teaching about the M&E system part of the system. They may talk a little bit about rolling stock, signaling system, but not a complete set of the M&E system in the mass transit system. And this course online, we will talk about a complete set of the M&E system, part of the mass transit system. And all the content here in this course I have accumulated from working in the actual mass transit projects in Thailand, more than 10 projects in Thailand. The subject has not been taught in any university in Thailand. Like I said, this course will be focusing and emphasizing on the electric railway engineering or electric railway system, from which the students can gain the required fundamental knowledge and be able to pursue his or her career as M&E system as an M&E system engineer. With that, I mean rolling stock engineer or signaling engineer or power supply engineer or AFC engineer, depot equipment engineer, for instance. So upon completion of this course, the students shall have the relevant basic knowledge and should be qualified to further his or her education to become an M&E system engineer, like I said, upon graduation from the university, equipped and ready to enter into the presently much demanding mass transit field of work. If a student has a degree in engineering and they they take this course, they should be ready to enter into a field of mass transit engineering in Thailand. The student will have the broad knowledge and be familiar with each of the main systems comprising the M&E system part of the mass transit projects and will learn about functions and components as well as the design consideration. By that I mean design criteria and design concepts of each system. So what is the electric railway system and what is the M&E system? So if we search Google for electric railway mass transit, we would get something like this. Okay, this is what we would see if we search for electric railway mass transit. So you would have a pretty good idea what would the electric railway mass transit would look like. So so that was the electric railway system. So what is the M&E system? So in the construction of electric railway mass transit line, there will be two major parts or two major works in the project. Namely, the first one would be the civil work, and the second one would be what we will be talking about, the M&E system work. And there must be those two parts put together in order for the mass transit line to be able to commercially operate. And the two parts would be contracted to two different groups of contractors and or suppliers, at least two different groups. Obviously, the civil work part would be dealing with the construction of stations, related buildings, building electric and mechanical works, E&M work. You can take note here that we have M&E and then we have E&M. So in Thailand, in mass transit industry in Thailand, if we talking about E&M, we mean the electrical, the mechanical works in the building, in buildings, in infrastructure, so on and so forth. But if we are talking about M&E system, we would mean the M&E system part of the electric railway system that I would be introducing later. So the civil work would be dealing with the construction of station, buildings, in works, related utilities works, elevator structures, probably also track work. So what is the M&E system? In Thailand, we call it ระบบรถไฟฟ้า so what is it? What is the M&E system? So M&E system part of the mass transit projects would consist of the following system. The first one would be the electric trains themselves. We call it rolling stock or RST. The second system would be the power supply distribution system PDS. For this, we will not be talking about power supply or eco IR, for example, but we will be talking about how the electricity be distributed in a mass transit system. And then we will have signaling system SIG. And the next one would be communications systems COM, which comprises of backbone transmission network, radio system, phone system, master clock system, public address system, so on and so forth, CCTV system. And then we will have the supervisory control and data acquisition system or SCADA. Next would be the automatic fare collection system AFC. And then we will have platform screen door system PSD. You could take note that for the power supply distribution system we use PDS, but for the platform screen door system we use PSD. This is a little bit trivial, but just to let you know. And then we have depot workshop equipment DWE. Or we could say that anything above the rail would consider to be the M&E system. In order for the mass transit or the electric railway line to be able to commercially operate, there must be the 8 above M&E systems fully installed, tested, and integrated system-wide. And in this course, the student will be taught about the concept and the designs of the train's velocity profile simulation, which is the critical tool and is the integral part of the designing of the mass transit system. We have to do the train simulation first in order to design the system. And the student will be asked, okay, this is if I would teach the student what I have done. I did it many years ago, and nowadays there should be software or application that we can use to make it easier to do the simulation, but the main concept would remain the same because the science will not change, for 50 100 years. They would remain the same, but we can have a tool to make it easier to apply or to use, for example. And this is an example of a velocity profile simulation that I did for a mass transit system in Thailand. This is for my own purposes, have nothing to do with the project. So you can see that you can see here two different colors. The first one is the blue color. Second one is the pink color. The blue color means constant speed. In Thailand, we will define the maximum speed for the rolling stock as 80 kilometers per hour. All mass transit lines in Thailand, we define it like that. The maximum speed would be 80 kilometers per hour, except the red line, which we consider to be a commuter train, meaning that they would run from outside the city into the city, and from the city to the suburb to take commuters to take people from outside the city to come to work in the morning and take them back in the evening, something like that. So for the red line, the maximum speed would be 160 kilometers per hour. So like I said, we have two different colors here. The blue color would mean that we will accelerate the train depending on the track profile. The speed would depend on the model's characteristic and then the profile of the track. Okay, we will speed the train up to 80 kilometers per hour, and then we will running at constant speed at 80 kilometers per hour up to the point when we need to apply the brake in order for the train to stop at the exact position at the next station. If we apply the brake later, the train would not be able to stop at the location that they should be stopping, and that would not align with the platform screen door. So we need to apply, or the train need to apply the brake, the electric brake at the exactly point, every time, and the train would be stopping at the designated location at the next station, where the train doors will be aligning with the platform screen doors. And the pink line, we call it coasting, meaning that when we reach the 80 kilometer per hour, we will turn off the power, turn off the motors, and then let the train roll, using its kinematic energy or whatever. So to save, we do that to save energy, and the train the speed would be decreasing up to the point we also need to apply the electric brake in order for the train to stop at the designated location in the next station. For costing, we would save energy, but obviously the time will be increasing. So it depends on the operation scheme. In the morning, in the morning rush hours, we time is important, so we will not do the costing during the rush hours in the morning or in the evening, but maybe in the off-peak period. In the off-peak periods, we can do the costing to save the energy. So this is the velocity profile simulation that we need to do before we actually design a mass transit system, because we will know the all the velocity along the line. We can determine the power that we need to apply. Then we can after that we can get many useful information like this. When we do the velocity simulation, that would lead to many other applications that we can do. This one we call it energy calculation. In mass transit, we would have the forecasted line loading, meaning the we would estimate the passenger flow, and then by using the passenger flow in the unit that we use would be passenger per direction per hour, and then with that figure we can determine how many trains we need to run, in the what would be the headway in the peak periods, what would be the optimum headways in the off peak periods, and then we can determine how many trains that we need to run during each period, and then we would get something like total kilometers per year, total train hours per year. Then we will get the total energy, total megawatt hour per year, and we can estimate the average, daily capacity, something like that. This is also what I did for a mass transit project in Thailand, and again for my own educational and engineering purposes. Have nothing to do with the project. So now we will talk about the general guidelines of this course. Again, I said that before, this course is intended to introduce the students to the fundamentals of the M&E system, of the electric railway system to enable the students to acquire the necessary knowledge about its functions, components, system configuration, and most importantly, the design consideration, which are design criteria and design concepts. And in this course, we intend to talk about the fundamental engineering methodologies. We'll be teaching about any specific product or any specific brands of a supplier or something like that. And like I said, this if I'm not mistaken, this will be the first ever course of its kind, combining all the M&E system in one course, being taught anywhere in Thailand. So we will look at the courses outlines. The first chapter would be introduction. That is what I'm talking about right now. The second chapter that we will teach would be signaling system. We bring up this topic first because signaling system is very important topic in mass transit system. We need to understand signaling system first before we can move forward. So I bring up this subject first, and then in chapter 3 we will learn about electric trains or the rolling stock. Chapter 4 would be power supply distribution system. Chapter 5 would be communication system. 6 would be SCADA. 7 AFC. 8 platform screen door. Chapter 9 depot workshop equipment. And chapter 10 we will learn a little bit about operation control center or ECC. What is OCC? What is the OCC? Who will be working in the OCC? And then the last chapter we will talk about velocity profile simulation. For the signaling system, okay, first we will talk about the main purposes of having the signaling system in mass transit system. Why? What are the purposes? This is rather a confusing topic for many I would say many engineers that I have worked with. They don't really understand the concept of signaling system. Okay, just to be just to have just to be exact or to have the same understanding. There are only three main purposes of having the signaling system in mass transit projects. The first one would be determining train locations. We should be able to identify each of the train location in the system. The second purpose would be to maintain safe distances between all the moving trains in the system. The first purpose would be performing all the required signaling functions. So there are only three main purposes for having signaling system in a mass transit project. So when we know what are the purposes in having the signaling system, we will then learn about the methodologies or the method how we can achieve those purposes. So the first one, we will be learning how to determine the train's locations. The method that we use are like track circuits, electric signal transmitters like beacons, balances, tags, transponders, is whatever you want to call them. And then we will talk about train-borne GPS devices. This is obviously one of the thing that we can use to determine location of an object or whatever. And then for the second purpose of having of having the signaling system in a mass transit project is maintaining safe distances. For that we have two methods, two system to do that. The first one we call fixed block system, and the second one would be moving block system. During my years working in mass transit projects in Thailand, I often heard engineers arguing about what was the fixed block, what was the moving block system. They were still confused about those two systems. And another thing that we would heard that is also moving block system is communication based train control or CBTC. That is also a moving block system. We will also talk about that. And then the third purpose of having the signaling system would be performing all the required signaling functions. In mass transit projects, there are three main functions that we would need to have. The first one would be the automatic train protection ATP. Second one would be automatic train operation ATO. And the third one would be automatic train supervision ATS. We will talk about those. And then we will talk about system configuration, how all the signaling system put together. We have something called European Train Control System ETCS, and then we will have Chinese Train Control System called CTCS, and then we will have Japanese Train Control System, and they call it Digital ATC or DATC. Those are three configurations that are being used nowadays in mass transit projects. And then we will talk about something called movement authority comparison. We will compare moving authority between the three configurations. Moving authority means that a distance that we would allow the train to move forward to, at one point the train need to stop in order not to run into another train, for instance. And the next topic that we will talk about is design consideration. In each and every system that I will talk about, we will talk about design consideration, which are design criteria. What would be the criteria that we need to consider in order to design the signaling system? What are the requirements? And then after learning the design criteria, we will talk about design concepts. How do we design the signaling system in a mass transit system? How do we design a fixed block system? How do we design the moving block system? And then the last topic, we will look at all the signaling system in the Thailand mass transit system, like which line uses which type of signaling system. And the next chapter would be erratic trains or rolling stock. For rolling stock, okay, we will introduce a little bit about the rolling stock. Then we will talk about major components. We will talk about the body. We will talk about couplers, which are semi-permanent couplers and the automatic couplers. When a train is connected to another train, we use automatic couplers. But when a train car is connected to another train car, we will use the semi-permanent couplers. We will talk about that in detail later. Then we will talk about bogies. which are model bogies and trailer bogies. And then we will look at the traction models. We will introduce the student to direct current models or alternative current models. We will talk about synchronous models. We will talk about permanent magnet models. We will talk about asynchronous or induction models, linear induction models, linear synchronous model. And then we will talk about train information monitoring system or TIMS in the loading stop. The next topic will be propulsion and braking system in electric trains. We will talk about propulsion or traction. Traction is another word for propulsion. How the train is moved forward. We will talk about propulsion or traction system, and then we will talk about braking system. How we can brake a moving train. We have electric braking and friction braking. We will talking about those, and then we will talk about brake bending. Sorry. Like I just said, we for braking of a loading stock, we will have electric braking, and then we will have friction braking. And electric braking alone cannot completely stop a train. So we need to use friction brake to stop the train. And to do that, we need to blend both electric braking and friction braking together in order to stop the train at a designated location. We will apply the electric braking first, and then when the train is slowed down to a certain speed, then the friction brake will come in to completely stop the train. And then we will talk about wheel slip and slide protection, WSP. We have to have methods to prevent the wheels from slipping and sliding. And then the next topic we will talk about principle of train movements. How what are the principles of train movements? How how the trains move. Uh, First, we were talking about equation of motion. This is important. Now we need to understand this first in order to move forward. And then we were talking about tractive effort models, characteristic curve. Each model have its own tractive effort curve. And then they also will have its. They will also have their own braking effort characteristic curves. And then we will talk about how do we control the motors for powering and braking. You know, we have to have a method to control how we supply the electricity to the motor to control the powering and the braking of the motors. And again, we were talking about design consideration. What are the design criteria for designing a loading stock? And then we will again talk about design concepts. What are the concepts that we use to design an electric train? And again, we will talk about all the loading stock in Thailand. which line uses what, which loading stock from which supply or something like that. And for those, we will divide it into conventional rolling stocks, monorails, and then high-speed trains. Thailand will is in the process of building high-speed lines. So there will be high-speed trains also in Thailand, and we will talk about that. Then we will talk about special topics. For special topics, we will introduce the student to the diesel locomotive, electric locomotives, and then the diesel electric multiple unit, or DEMU, that are used in Thailand in the railways network in Thailand right now. And then we will talk about bimode trains. What are bimode trains and how they are different from hybrid trains? This is another confusing subject for many engineers as well. And then we will talk about linear induction motor and maglev trains. This is also another interesting topic. And then we will talk about hydrogen power trains. In Thailand, we are now trying to study hydrogen power trains in order to reduce the pollution from diesel trains. So that topic would be now studied in Thailand, and we will talk about that. And then we will talk about light rail vehicles, LRV and trams. In mass transit system, you will heard two what we call two phases. You will hear you will hear heavy rail and light rail. In Thailand now, we in all the mass transit lines we use heavy rail trains, and then we also will have light rail trains. So we will talk about that and see what are the differences between the heavy rails and the light rails. The next chapter would be power supply distribution system. For the power supply, we will again talk. The first subject would be introduction, and the second one would be the system configuration. For the system configuration, we will talk about the third level power supply distribution system, the 750-volt third level system, which is used in I would say most of the mass transit lines in Thailand, except two. The next system configuration would be the overhead continuous power supply distribution system, or OCS system. And in this course, we will talk about the 2 times 25 kV OCS system. In Thailand now, we have two lines that are using OCS system. One is the airport railing line, and the second one would be the red line. The airport railing line, they use regular 25 kV OCS system, but for the red line, they use 2 times 25 kV OCS system, which is a new system. So in this course, we will talk about the 2 times 25 kV OCS system, but we will compare with the regular 25 kV system to see all the differences. Next, we will in the power supply distribution system for a mass transit system, we will have other components for the power supply distribution system, not just the third rail or the OCS. And regardless of the system, the configuration that they use, like third rail or OCS system, all the mass transit line, they would also have the following systems for the power supply distribution. First one would be the backup power supply system. We will discuss about that. The next one would be the UPS system, the uninterruptible power supply system. Now, we need to have that. Okay. Then we will talk about the control of the power supply system. How do we control the power supply system? Then we will discuss another very important subject for power supply distribution system in mass transit systems, which is the stray current corrosion control. We need to control the corrosion that is caused by stray current. And then we will talk about earthing and bonding in mass transit system. And then we will discuss major components of the power supply distribution system. We will discuss the 65 kV and 115 kV switch gear. In Thailand, we have two incoming voltages from the what we call Metropolitan Electric Authority, MEA. For the red line, we have 115 kV. For the MRT line and the Sky train, we have 69 kV coming in. Anyway, in power supply distribution system, we will step down the high voltage to the medium voltage, and then to the voltages that will be used in the system. So we will talk about the high voltage switch gears. We would have 69 kV and 115 kV. And then we will, like I said, the high voltage will be reduced to the medium voltage. So we will talk about the 69 24 kV and 115 24 kV, 115 25 kV transformer. And then we will talk about 24 kV and 25 kV switch gears. And then we will talk about 24 and 460 volt service transformer. And then 24 kV AC and 750 volt DC traction transformer and rectifier. For the third layer, we have to convert the AC to DC from 24 kV AC to 750 volt DC to be fed to the third layer. And we will talk about the auto transformer used for the 2 times 25 kV OCS system, which are converting the 50 kV to 2 times 25 kV to be used in the 2 times 25 kV OCS system for the red line. Then again, we will talk about design consideration. What are the design criteria to be considered for designing the power supply distribution system? And then again, the design concepts. Then again, we will talk about the power supply distribution system in mass transit system in Thailand. And for the special topic, we will talk about the wireless power transfer. As I said, we have two main systems to supply the electricity to mass transit, namely the 750 third rail system and the OCS system. But there is another way that we can supply electricity to the train, using wireless power transfer. This system is being experimented, but they also this system is also being used for the maglev trains. And for chapter 5, communication system communication, uh, after the introduction, we will talk about the system configuration and components. And they there are 6 components for the communication system. We will talk about the backbone transmission network, BTN, which is like a road for all the data to travel in the system. Then we will talk about the radio communication system, telephone system, master clock system, public address system, CCTV system, and then again, design consideration, design criteria, design concept. And we will talk about communication system in Thailand's mass transit system. Next chapter would be a SCADA, supervisory control and data acquisition system. We will talk about function requirements. We will talk about system configuration. We will talk about interface requirement. This is another important topic because we need to know the interface requirements, which equipment need to be monitored and controlled. And again, we will talk about design consideration, design criteria, design concepts, and then look at the SCADA system in Thailand. For automatic fare collection or AFC, we will talk about the system configuration, functional requirements. What are the functions that are required, for AFC? And then we will talk about design consideration as usual, criteria, concept, and look at the AFC system in Thailand. Next one would be the platform screen door. Again, we were talking about the system configuration, performance requirements, which is very important. What do we want the platform screen doors to do? And then we will talk about major components of the platform screen door and design consideration, criteria, concept, and PSD system in Thailand. And chapter 9 would be depot workshop equipment. For depot workshop equipment, we will first talk about mention philosophy, because in the depot the main purpose of the depot is to maintain the rolling stock. That would be the major purpose of having a depot in mass transit system. And we will talking about the philosophy, mention philosophy. Then we will look at the depot layout, and then what will we have in a depot. We have a heavy maintenance workshop, we will have a routine maintenance workshop, something like that. So we will look at the whole layout. We will have test tracks, for instance. We have washing plant. We have a wheel laid equipment, something like that. So we will take a look at the whole depot layout, and then we will discuss major tools and equipment. How we what will be used in the depot, and then we will talk about the design consideration, criteria, and concept. How do we design a wheel lathe, for instance? How many equipment in the depot that we need for the system, something like that. And then we will look at the depot workshop equipment in Thailand. For OCC, Operation Control Center, we just will briefly look at the OCC functions and configuration, how the OCC would be arranged, who would be working in the OCC, the chief, the chief, what we call the OCC chief, the line controllers, the depot controllers, the engineering controllers, for instance. And then we will discuss a little bit of fallback operation control center, FBOCC. And then the chapter 11, we will teach how to do the velocity profile simulation. And again, this is something that I did for a mass transit line in Thailand. This is just for my own personal and education evaluation purposes. How the train would run in this project. We have, like I said, we have both a constant speed and coasting. And this is one of the student works. After I teach the student, I ask them to do a simulation, and this is what one of them came up with. This is the distance where the train reached 80 kilometers per hour in 25.31 seconds, and then they will run at constant speed up to the distance of 11.516 meter, and then the kilometer, this is the chain net, so they will run about 1 kilometer. And normally the distances between stations in mass transit, when we first decide the station or to determine the location of the station, normally we just put them 1 kilometer apart. That's just for basic design. And then we will look at that location to see if it is actually appropriate. If it is not, we will move it further or move it back just a few meters to make it better. But not normally we will put station 1 kilometer apart. That mainly due to the characteristic of the rolling stock. How they accelerate. How they brake. So this is what one of the students did. One of the students did, the simulation, which is so this is the distance between section is 1.496 kilometer. So this is pretty good. and that is what my course will be talking about. And before we finish, let me take a look at Thailand's mass transit network. This is what we have now. We have about 6 lines. It depends on how you count it, because the green line, we have the light green line, we have the dark green line. So anyway, it's about 6 lines now, and then we will increase the network to include a few more lines. Maybe the total of 10 lines, something like that. This is just the metro system, meaning the system that will be running in the city. And then we will have high speed lines. We will have quite a few high speed lines in Thailand. And then we also will for the intercity line, conventional railway, we will build what we call double track lines, in Thailand, all over Thailand. So we will normally, actually, in the future, we will all the railway system network in Thailand will be what I just said, double track lines. For the lines that may not be rectified, but other M&E system will still be applied, like rolling stock, signaling system. In Thailand, they are now using the ETCS level 1 for the red line, and will be using for all the double track lines. So the M&E systems that we are talking about in this course still can be applied for the double track lines. The communication system would be the same. Depot workshop equipment would be the same. And we will also have monorail lines in provinces, and also we will have the light rail lines in the provinces. So there would be many opportunities for railway engineers. Okay, before we end this presentation, after I introduce my students to what we will be learning in this course, I would leave them with something that I think that they should know or should be aware of, like life philosophy. Life philosophy. Whatever you are, just try to be a good one. I heard this phrase from actually a little kid in the U.S. when I was in the U.S. Whatever you are, just be a good one. Whether you are an engineer, you are a thief, you should be a good one. Whatever you are, just try to be a good one by simply just doing your duty the right way. And for the working philosophy, every task, no matter how hard, difficult, will always have its own proven methodology, because we will not be the first one to do something. Every task, somebody else must did it before. So it will have its own proven methodology. We just need to find that, and simply start with that and apply our own knowledge and experiences to perhaps make it better. And what you should not do, the don't, not knowing what you should know. This is quite important. If you don't know what you should know, that a minus. Don't let that happen. And what you should do, what you should do, knowing what you not know. Okay, you may not know everything, but what you should do, or what you should be able to do is knowing what you not know. You should know. You have to realize what you don't know. And if it is something that you should know, then you should study. You should look into it. And this is just something that we will hear a lot in the industry. The show proud. This is I recommend that no show proud. Show proud means just presenting yourself with something that you don't really know. Just to make you look good. Just we call it show proud. Don't do that. Okay. That's all for the my the introduction to my introduction to electric railway engineering fundamentals, or the M&E system part of the electric railway system. So thank you for watching, and have a nice day and stay very healthy. Thank you. So